Okay, so let's talk about the questions in the first quiz. Okay, first quiz. So the first part is the simplify the difference quotient. Okay, so we are looking at this quotient, f of x plus h minus f of x divided by h. Okay, so for a given function f, we want to simplify this quotient. So let's assume f is negative 2x plus 5. Okay, negative 2x plus 5. So the first part on the numerator, f of x is given. It's just this negative 2x plus 5. So the difficult part is this f of x plus h. Okay, so what is f of x plus h? So I already repeat this a lot of times in the beginning of the semester, right? We put a box for the input. So this formula means f of a box is negative 2 box plus 5. So now you just put x plus h in the box, right? In the box. So let's repeat that. This is negative 2 a box and x plus h in the box, and then plus 5. Okay, plus 5. So now let's simplify this a little bit. So replace the box with the parentheses, right? Negative 2 x plus h plus 5. So now distribution rule. Okay, so negative 2 times x, negative 2 times h. So we got negative 2x, negative 2h plus 5h. Okay, so this is the first part of the numerator. Okay, numerator. So now let's put the whole thing together. So this is the first one, the first part, negative 2x minus 2h plus 5. And the minus negative 2x plus 5 divided by h. Okay, divided by h. So negative 2x minus negative 2x cancelled. 5 minus 5 cancelled. So we have negative 2h divided by h, which is negative 2. Okay, so here h is also cancelled in division. Okay, so next example. So suppose f of x is x squared minus 2x plus 1. Also simplify this quotient, right? Simplify. F of x plus h minus f of x divided by h. Okay, divided by h. So again, the problem is f of x plus h. Okay, the first one in the numerator. So we'll assume here is a box. So what is f? F is a box squared minus 2 box plus 1. So what's in the box? X plus h. Okay, so this is x plus h squared minus 2 times x plus h plus 1. Okay, plus 1. So now let's look at the quotient. F of x plus h minus f of x divided by h. So this is the first part is this whole thing, right? So x plus h squared minus 2 x plus h plus 1, and then minus the whole f of x minus f of x. So f of x is x squared minus 2x plus 1, and then divided by h. Okay, and then divided by h. So now expand the first complicated part a little bit. So x squared plus 2xh plus h squared. So that is this term. X plus h squared is these three terms. Okay, and then minus 2 times x minus 2h and then plus 1. And then the f part minus x squared plus 2x minus 1 for the second middle bracket divided by h. Okay, divided by h. So now let's cancel some terms. X squared minus x squared cancelled. Negative 2x cancelled. Positive 1, negative 1 cancelled. So we got 2xh plus h squared minus 2h divided by h. So now h cancelled. We got 2x plus h minus 2. So that's the answer. Okay, that's the answer. So the key step is this step. Okay, we find what is f of x plus h. And then cancel and then simplify the fraction. Okay, so the next part is even and odd function. Okay, so what's an even function? Even function, we have to have f of x is equal to f of negative x. They are exactly the same. Okay, so odd function means f of x is the opposite of f of negative x. Okay, yeah. So if it's not even, it's not odd, you just put neither. Okay, you put neither. So now let's look at the first example. Okay, so f of x is negative 3x plus 2. What is f of negative x? So this is negative 3. So now the input is, let's still use a box. Okay, so the input in the box is negative x. So negative 3 times negative x. So this is positive 3x plus 2. Okay, plus 2. So this is f of negative x. Okay, so now if you look at this f of x and f of negative x, this term they are the same, but the first term they are the opposite. Okay, so for even function, all the terms has to be the same. For all the functions has to be opposite. So this is not even or odd, because the first part opposite, second part the same. Okay, yeah. So this is neither. The second example, f of x is x cubed minus 3x. So what's f of negative x? F of negative x is negative x cubed minus 3 times negative x. The input is negative x. So f of negative x is negative x cubed plus 3x. So now you see they are all opposite. Here is x cubed, here is negative x cubed, opposite sign. Here is negative 3, x is positive x, opposite sign. So this is all opposite, is odd function. Okay. Okay, so this question is transformation of functions. Okay, transformation of functions. The most important thing is to change the input or change the output. Okay, so let's say if it's f of x. So if you add a negative x inside, so this means this negative side is inside. So this means you change the input. Change the input means reflect with respect to y-axis. Okay, you change the input, so this is the case. You have this blue curve, reflect with respect to y-axis, you got the same curve. Okay, get same curve. So now if you put the negative sign outside, okay, so it's negative f of x. Okay, so now this means you change the output, so this is reflect with respect to x-axis. Okay, so that's the second example. Okay, second example. So reflect and then move to negative 2. Okay, so reflect this way. So in the beginning, the blue curve is this, and then you reflect it with respect to the x-axis. You got this purple curve, and then this means move to the left too. You got this red curve, the answer part. Okay, so if negative sign is outside, that means reflect with x-axis. If it's inside, reflect with respect to the y-axis. Okay, yeah. And I already gave you the table in the classroom, right? There's a table of all the transformations. So now the domain of functions. Domain of f of x. So that means where the fx is well defined. Okay, well defined. We have to check two conditions, at least for my 30 of two conditions. So first, denominator is not equal to 0. And then second condition, you take square root of non-negative, not positive, non-negative numbers. Okay, you need to check these two conditions. Okay, so let's look at example. So if f of x is 5x minus 2 over x squared minus 2x. So what's the domain of f? There's a denominator, there's no square root, so we need to check condition 1. Denominator is not 0, so we need x squared minus 2x is not equal to 0. So x times x minus 2 is not equal to 0. X is not 0 or x is not 2. Okay, so this is the domain. All the numbers except 0 and 2. Okay, 0 and 2. So now let's change f a little bit. If this is f of x is square root of x squared minus 2x. Okay, then we need the second condition. Second condition means non-negative. Square root of non-negative number. So what means non-negative? This is greater than or equal to 0. Okay, greater than or equal to 0. So we got x squared minus 2x greater than or equal to 0. So x times x minus 2 is greater than or equal to 0. Okay, now this is a harder case. We have inequalities, right? So first solution is 0, second solution is 2. So now we need positive negative sign. So positive switch, negative switch, positive. So what's the solution? Here and there, right? So solution is 2 to positive infinity, and we union. Okay, we use big U for union, and the other one is negative infinity to 0. Okay, infinity to 0. So it's everything except the numbers between 0 and 2. Okay, between 0 and 2. So that's the second example. So now the third case is a little bit complicated. If we put radical in the denominator, so suppose f of x is 5x minus 2 divided by square root of x squared minus 2x. Then we need to check two conditions. Denominator is not 0, and we take square root of non-negative number. So you put them together. That means radical x squared minus 2x is not 0, and radical x squared minus 2x. So here, I forgot. So these two endpoints are closed because you can equal, right? There's an equal sign in equality. So x squared minus 2x is greater than or equal to 0. So you put these two conditions together, right? So here is greater than or equal to 0 under the radical sign. The radicand is greater than or equal to 0. This is not equal to 0. So we got x squared minus 2x is strictly bigger than 0. Okay, so here's the radical sign in the denominator. Okay, you take square root of positive number. Okay, positive numbers. Then we use the same number line. Okay, so now we get two open intervals, negative infinity to 0, open union to positive infinity. Okay, so check these two conditions for the domain. Okay, for the domain of f. The inverse function, this is the easiest case, right? Easiest case. So inverse function. So f of x is 2x minus 7, and g of x is x minus 7 divided by 2. We want to know whether they are inverse of each other. Okay, so we find inverse of f. Okay, so what's step 1? Okay, so step 1, we change f of x to y. So y is 2x minus 7, and then step 2, solve for x. Okay, so y plus 7 is 2x divided by 2 divided by 2. We got x is y plus 7 divided by 2, and then step 3, change x to f inverse of y. So f inverse of y is y plus 7 over 2. And then we compare this and the function g. They are different. They're not exactly. Here is minus 7, here is plus 7. Okay, the letters doesn't matter. Here the input is y, here the input is x. We can use any letter. Okay, but the structure are different. Here is minus 7, here is plus 7. So they're not the same. So f and g are not the inverse of each other. Okay? Yeah. Okay, so now this is operations of two functions f and g. Okay, f and g. So number one is very easy. Okay, so number one we have f over g of x. So this is by definition f of x over g of x. Right, so what is f of x? X squared minus x. What g of x? 2x plus 1, and that's it. That's the answer. Okay, that's the answer. So in the exam, you may have f times g of x. So which means f of x times g of x. F plus g of x, or f minus g of x. So this means f of x plus g of x, and f of x minus g of x. Okay, so let's put this. So multiplication, so this is x squared minus x times 2x plus 1. Okay, and then you use FOIL, right? FOIL, and then simplify. FOIL, and then you got the answer. Okay, yeah. F plus g, you just add them, right? So this is x squared minus x plus 2x plus 1. So combine these two in the middle, you got x squared plus x plus 1. And the subtraction, x squared minus x minus g, 2x plus 1. So this is x squared minus x minus 2x minus 1, so which is x squared minus 3x minus 1. Okay, yeah, so they're not in the list, but you have to know, okay, you have to know the basic operations of functions. The next two questions are compositions, okay, are compositions. So compositions means we apply the functions one by one, okay, so what's the direction? We apply this way, okay, from right to left, okay, from right to left. So now let's first look at question 3 here. Question 3, G compose F, so we will use a circle for composition, okay, G compose F of 3. So this means we first apply function f to 3, so this is first function, okay, and then we apply g to f of 3, okay, so this is the second function, okay, second function. So let's use arrows, right? So first 3, and then we use function f, so we will get f of 3 here, okay, we'll apply function f to number 3. And then we got f of 3, so that's the input for the second function g. So g of this new number f of 3, you got the answer for the composition function. Okay, so what's f of 3? This is 3 squared minus 3, which is 6. So it's g of 6, so this is g of 6. So this is 2 times 6 plus 1, which is 13. Okay, which is 13. So this is the understanding of composition. Okay, we apply this function first, the function closest to the number, and then we collect the next one, next one, next one. Okay, so yeah, so now let's write it down. If you're not familiar or good at this part, you can write down 2 steps. First, just write down f of 3. Okay, so this is 3 squared minus 3, so this is 6. Okay, so the first function f is done, and then the second function g applied to this f of 3, which is 6. So g of f of 3 is g of 6, so this is 2 times 6 plus 1, which is 13. Okay, which is 13. So now let's go back to number 2. So question 2 is g compose g of x. Okay, g compose g of x. So this is what? We first apply function g. Okay, so this is our first function. And then we got g of x, and g of x is the new input for the second function. So second function is also g. Okay, so there's no function f here. And then we got g of the box, so g of x is in the box. Okay, is in the box. So what's g of x is 2x plus 1, right? So the second function, g applied to this box, so it's 2 times the box plus 1. So what's in the box? This part, 2x plus 1 is in the box. Okay, so this will be 2 times 2x plus 1 plus 1. Okay, this is the composition. Apply the second function to the output of the first function. Okay, so g, compose g of x is, first we apply g to x, and then we apply g again to the g of x. So this is 2 times 2x plus 1 plus 1. So distribution, this is 2x plus 2 to 4x plus 2, sorry, plus 1, so which is 4x plus 3. Okay, 4x plus 3. So this is the composition. Okay, we apply one function and then we apply another function. So now let's look at the graphs. Okay, graph is also very important. Okay, so we have two functions, f and g. Okay, f and g. So let's look at the first question, the domain. Okay, the domain. So what is the domain of f? That means all the possible x. Okay, so domain is on the x-axis. So this is the domain. Okay, so you project all the curve to the x-axis. This is what you got. Okay, so you project this way. That's all the possible x. Okay, you can see is between -2 and 6. Okay, that's the domain of f. So now for domain of g, because there are two arrows, right? Two arrows means it's continue forever. Okay, so when you project everything to x-axis, you will get the whole line. Okay, the whole line, whole x-axis, so we use -infinity to +infinity for the domain. Okay, this is the whole x-axis, whole number line x-axis. Okay, yeah. So this is the domain, we project everything to x-axis. So now let's look at the range. So for the range, we project everything to the y-axis. Okay, so this is all the possible y, so we project this way. Okay, the blue line projected to y-axis. So where is the minimum? So this is the minimum. -2. Where is the maximum? +6. So it's -2 to +6. So they looks like same answers, but they're not. Okay, this is on x-axis, and the other one is on the y-axis. Okay, yeah, so most cases are different. Okay, just for the special f, they are the same. Okay, they are the same. So now for g, okay, for g, so still these two arrows means go down forever, right? So now we project everything to the y-axis. Okay, so we'll go to y-axis from both directions. So you can see there is a maximum 0 and you got all the numbers below 0. Okay, so the range is for the y-axis. Okay, so the range is everything below 0, so it's -infinity to 0. Okay, so for g, domain and range are different. Okay, domain and range are different. Okay, so now let's look at the next question. X-intercepts and y-intercepts. Okay, y-intercepts. So what's the x-intercepts? X-intercepts is the point on the blue curve and on x-axis. Okay, so this is the x-intercept. Okay, so these two are the x-intercept. Okay, it's where the blue curve, the graph touch what x-axis. Okay, x-axis. So for function f is 0.4, 0. But in your test, it's a web work final. So they may put x is equal to, then the intercept will be only number 4. Okay, you only put number 4 here. Okay, same thing. Here they will ask you x is, what's the x-intercept of g? So you only put 0 and then use comma, separate the answers. So g, the other intercept is 3. So two intercepts function g, 0 and 3. Okay, 0 and 3. Okay, yeah. So in the web work, sometimes you answer just the number part. Okay, the x-coordinate of x-intercept and y-coordinate of y-intercept. Okay, yeah. So where's the y-intercept? So let's change the color, right? Y-intercept is where this blue curve touch y-axis. Okay, so this is y-intercept, and this is a special one. Okay, the origin is x and y-intercept. The blue curve touch y-axis also at this origin point. Okay, so the answer here, y-intercept is the point 0, 4, or is the point y is 0. Oh, sorry, y is 4. This is for the function f. Okay, and function g, y-intercept is the origin 0, 0, so you can say this is 0. Okay, this is 0. So there are just two ways to write down y-intercept. Use point or use y-coordinate. Okay, y-coordinate. So you should be careful when you work on line rated. Okay, they want you to put the point or they want to put the number. Most cases they want you to put the number. Okay, put the number. So now increasing and decreasing questions. Okay, increasing and decreasing functions. So increasing means go up like this. Okay, decreasing means go down. When you look at the whole curve, it's go down. Okay, yeah. So maybe it's go down slower like that. That's decreasing. Okay, yeah. Go up. Okay, yeah. So now what's the question? F is increasing on. So you look at function f is going down. Only going down, never go up from left to right. So none. Okay, none. And decreasing on the whole domain, right? This is the domain of f from -2 to 6. Okay, so when you ask is increasing or decreasing, we put the domain. Okay, put the domain. It's a part of the domain. Okay, so function g, where is function g is increasing? So where function g go up like this? So is this part and that part. Okay, so this part, look at domain is -infinity to 0. Okay, so project everything to what x-axis. So on x is here, the curve is going up, is increasing. And this is the midpoint 1.5 to 3. So x is increasing here. Okay, yeah, so you put the union. If there are two intervals, you put the union. That means this interval and that interval. Okay, yeah. So when this curve is going down, so it's from 0 to 1.5, this is going down. And then after 3 is going down. So 0 to 1.5 and after 3 is going down. That's how we read the graph, basic part. Okay, basic part. So now harder part. Okay, so now we want to know what's f times g of 3. Okay, f times g of 3. So let's put it up there. So we have f of 3 times g of 3. So this is f of 3 times g of 3. So where's f of 3? You go to 3, you go to this point on the curve. Okay, so any point on the curve is x comma f of x. That's the graph, right? So this point is 3, f of 3. So what is f of 3? But you're looking at height, right? The y part is f of 3, so it is number 1. So this is 1. So same thing, g of 3, right? G of 3. So you go to 3. So this point is on the graph. So this is 3 comma g of 3. So the y-coordinate of this point is what? The y-coordinate is 0. So g of 3 is 0. So this is 1 times 0 is 1. So this is f of 3 times g of 3. Okay? Yeah. So now let's look at the other one, right? Okay, so let's look at the second question. F of 1 over g of 1 divided by g of 1. So what is f of 1? This point is 1 f of 1. So what is f of 1? 3. The height is 3. Okay? F of 1 is always the output. And g of 1. So g of 1, you go to 1. And this point on the graph, so this is 1 g of 1. So what's g of 1 is the height, so it's -4. Okay, so f of 1 is 3, g of 1 is -4, so this is 3 over -4. Okay, so that's the answer, 3 over -4. Okay, so next. So f of 1. Okay, so let's write down the relation, right? F of 1 by definition. What this means? This means first you got number 1, and then you apply function f. You got f of 1. And that's a number, and then you apply f again to this number. Okay, to this number. So let's first find this number. What's f of 1? We already did it, right? So you go to 1, and then you match the curve. Meet the curve here. This is 1 of f of 1. So f of 1 is 3. So now we know this number is 3. So apply f to this 3 again. You got f of 3. That's the second function, right? This is f of 3. So f of 3, so you go to 3 and then find the curve f. So this is 3, comma f of 3. Right, so what's f of 3? 1. So this is number 1. Okay, yeah. So this 1 basically means this is f of 3 and then this 1. Okay, this is 1. So now we use the same idea to find f compose g of 3. Okay, so now we look at this f of g of 3. So apply g first and then apply f. Okay, so it's number 3, and then you got g of 3, and that's the new number, and you got f of this new number. Okay, so what is g of 3 at this point? 3g of 3, so which is 0. So this is 0. And then the second part is f of 0. So this is f of 0, right? F of 0. So 0 is here. F of 0 go up. This is 0, f of 0. So what is f of 0 by the graph? 4. Okay, 4. So we first find g of 3. G of 3 is 0. And then f of 0 give us 4. Okay, yeah, that's the composition. We apply function and then another function after that. Okay, so now inverse function. Okay, inverse function, the last two problem. Okay, so first we want to find f of inverse 4. Okay, inverse 4. Okay, so what that means? Okay, what that means? So let's say this is some letter x. So let's rewrite by inverse function, right? Inverse function. So this means f of x is 4. Okay, so let's draw the pictures for f and f inverse, right? So let's assume f inverse send 4 to some letter x, some unknown number x, and then the backward, the reverse is function f. So function f send this x to 4. So f of x is 4. So now it's more clearer for us. So what is this f of x is 4? This means the y coordinate is 4. F of x is y, right? So y coordinate is 4 is this point on the graph. Right? So this is f of x is equal to 4, this point. The height is 4. Okay, so this point is x, f of x is 4. So what is x? You look at x, so it's 0. Right? The x part, the x coordinate of this point is 0, 4. So x is 0, f of x is 4. Okay, that's why f inverse is 0. Okay, f inverse 0. So now here is the same thing. That's the second example, right? So we assume f of inverse 1 is x. So this means f of x is 1, right? So f inverse sine 1 to x, and then f sine x back to 1. Okay, back to 1. So f of x is 1, so we know y, the height is 1. So the height is 1, we find this point. The height is 1, right? So this point is 3, 1. And this point is x, f of x. So we know x is 3, right? X is 3. So all the points on the graph has this formula, x, f of x, x, f of x. This is the key to solve these 3 questions. Okay, these 3 questions. Okay, yeah. Okay, so the last question they may ask you in the exam is whether the function is 1-to-1. Okay, it's 1-to-1. So how can you tell that? You look at the horizontal line. Okay, so if you only meet the graph once for every horizontal line, then this is a 1-to-1 function. Okay, so when you draw this horizontal line, how many times you meet? You meet these things 4 times. That means on all these 4 parts, they have the same y. Okay, so this is x1, x2, x3, x4. So you got f of x1 is equal to f of x2 is equal to f of x3 is equal to f of 4. So it's not 1 to 1. F send all these 4 input to the same height y. Okay, so this is not 1 to 1, that is 1 to 1. Again, 1 to 1 means you only meet the graph once for any horizontal line. Okay, yeah, so that's the end of quiz 1.